yesterday. This is an old multiple choice question. And I have had some students ask, like, why are we still doing multiple choice questions if the AP exam is free response? And what I say to that is that I think that multiple choice is still extremely important, because any one of these multiple choice could end up being one of the parts of the free response question. So let's go ahead and see what we have here. A compact disc manufacturer wanted to determine which of two different cover designs for a newly released CD will generate more sales. The manufacturer chose 70 stores. I think that's important. What I noticed there is that they did not take a simple random sample of 70 stores. They just simply chose 70 stores to sell the CD. 35 of these stores were randomly assigned to sell CDs with one of the cover designs, and the other 35 were assigned to sell the CDs with the other cover design. So listen, the fact that they have random assignment of these two different album covers is important, right? This is part of the experimental design. And the reason why we do random assignment is so that we create two groups which are roughly equivalent, so that if in the end there's a difference between the two groups, we know that it was caused by the treatment. So this random assignment is what's going to allow us to show causation. And we'll see when we look at the answer choices that this is going to be very important. All right, to finish up, the manufacturer recorded the number of CDs sold at each of the stores and found a significant difference between the mean number of CDs sold for the two cover designs. Which of the following gives the conclusion that should be made based on the results and provides the best explanation for the conclusion? So if we just look at answer choice A, it says that it is not reasonable to conclude that the difference in sales was caused by the different cover designs. Well, I think we already decided that because of this random assignment here, that we actually can show causation. And so I don't like answer choice A because it's saying that it's not reasonable to conclude that there was causation. In fact, as I look at answer choice B, it is not reasonable, causation. And answer choice C, it is not reasonable, causation. I can get rid of answer choices A, B, and C right away, which leaves me with two answer choices, both of which are saying it is reasonable to conclude causation. But we have to look at the end of the statements to decide which one is correct. So if we look at answer choice D, it is reasonable to conclude that the difference in sales was caused by the different cover designs because the cover designs were randomly assigned to stores. Well, that random assignment is in fact what allows us to show causation. And if I look at answer choice E, they're making reference to the sample size being large, which is a good thing and might help us determine a model for the sampling distribution, but that's not what allows us to say that there's causation. It's random assignment that allows us to show causation. And so the correct answer there is D. So hopefully you did okay with that one. And we are now ready to jump into today's lesson, which you already know what's coming at you here. Very straightforward with the learning targets. I was careful to make sure that I selected one FRQ from each one of the first 3 units in the College Board CED that are very exemplary. That's sort of our common type FRQs that you might see. And I actually had some help in choosing these problems, and I'll talk about that when we actually get to the problems. So there it is, exploring 1 variable data, exploring 2 variable data, and then what Mr. Murphy talked about with you yesterday on collecting data. And we're just going to go through 1 free response for each one. And so the way I'm going to handle it is I'm going to first take you through the thinking of the model solution, and we'll write up the model solution. But then equally important, I'm going to take you through the College Board rubric on how the graders actually go about assigning points to each one of these FRQs, which will give you some insight about how you should write your responses for the AP exam on May 22nd. All right, so let's jump right in here. Question number 1. And let me tell you, first of all, how I was able to select these questions. I went to some of my best friends in the AP statistics community, and I asked them, what is your absolute most favorite FRQ that might come from the first 3 units? And Mr. Darren Starnes was helpful enough to give me one of his favorite FRQs. Darren is an AP statistics teacher in New Jersey. He has also been a question leader at the AP exam for many, many years. So very well known within the AP statistics community. And he said his favorite problem of all time goes way back to 2005, question number 1 about caloric intake. So let's go ahead and jump right in and see what we can come up with first with the model solution, and then I'll take you through the rubric for grading it. So here's what it says. Number 1, the goal of a nutritional study was to compare the caloric intake of adolescents living in rural areas of the United States with the caloric intake of adolescents living in urban areas of the United States. A random sample, this is good, of 9th grade students from one high school in a rural area were selected. Another random sample of 9th graders from one high school in an urban area was also selected. Each student in each sample kept records of all the food he or she consumed in one day. The back-to-back stem plot below displays the number of calories of food consumed per kilogram of body weight for each student. Okay, so we've got this back-to-back stem plot here. And just to make sure we know what stem plot represents here, like if we look at, say, this here 3 and this 7, what that's telling me, I'm going to give you a little bit of a key here. That 3 and 7 is telling me 37. So the number here is the tens, and then the number that is the leaf is the ones number. So this represents 37 calories. And on the other side, well, look, there's a 37 calories on the other side as well. Okay, so we have a back-to-back stem plot here. So here, part A says, write a few sentences comparing the distribution of daily caloric intake of 9th grade students in the rural high school with the distribution of daily caloric intake of 9th grade students in the urban high school. Okay, the important words here are compare the two distributions. And we actually talked about this on Monday when we did one variable data analysis. And there are some very specific things that need to be addressed when you are asked to compare distributions. And the acronym that we had to help us remember that was SOX. And then I actually added on the last part to make sure that we include context when we answer that question. So we're just going to go through an order here. All right, S represents the shape of the distributions. And we want to make sure that we comment on both of those. So first, if you look at the urban, the shape of it, it looks like we have most values sort of in the 20s. And then as we get into the 30s and the 40s, it starts to taper off a little bit. So as we're moving to the right, we're getting less and less values, which is telling me that distribution is skewed to the right. So I'm going to say this: the shape of the distribution. And right here, I'm going to go ahead and take care of handling the context of the problem right away in this first sentence. The context here, it's the distribution of daily caloric intake. And listen, once we've established the context once, we don't have to continue to say it over and over again, right? So we're done with that. And we're going to start for the urban students. And for the urban students, we said that the distribution is skewed right. Now for the rural students here, if you look, it's maybe got a center somewhere between 30 and 40, and it seems to be sort of equally distributed on either side of that center. So I think I would call that symmetric, or maybe to be a little bit more safe, I'd say fairly symmetric, because it's not going to be perfectly symmetric. So I'm going to say, while the distribution is fairly symmetric for the rural students. So that takes care of comparing the shapes. All right, the next thing that we would want to comment on is any outliers that we might see. And I'm looking at both of these distributions, and I don't see any single values that are far away from the others. So I'm just going to go ahead and say that I don't see any outliers. I'm going to say there are no outliers for either distribution. All right, that takes care of outliers. Next up is to compare the centers. Now, we could use the mean or we could use the median to measure the centers, but the important thing here when you're comparing is that you don't actually have to do any calculations. You just have to make a comparative statement about the center of one distribution compared to the other. Now for urban, the center is going to be, I don't know, maybe somewhere between 20 and 30. And for rural, it's somewhere between 30 and 40. Clearly, the center of the distribution for urban is less than the center of the distribution for rural. So that's just what we're going to put into words now. Okay, and we're not going to even specifically reference the mean or the median or give any values here. We're just going to say, sort of generically, that the center of the distribution for the urban students is less than, there's my comparative words, less than the center for the rural students. So that takes care of the center, and the last thing we need to take care of is the spread, which we could measure with, say, the range or the IQR or the standard deviation, but once again, we don't have to calculate specific values. And so let's just look in general at the spread. For urban, the lowest value we have is 26, the highest value is 42. For rural, the lowest value is 32 up to 51. So those are fairly close there. But I think that urban has a little bit less variability there if you were to just compare their ranges, right? So we're going to say the variability for urban students is less than for rural students. So that takes care of spread. We definitely took care of context right up front. So I believe that we have a model solution here for comparing those two distributions. All right, let's move to part B, which says, is it reasonable to generalize the findings of this study to all rural and urban ninth grade students in the United States? And I think this is the word that's important here. Can we generalize to a larger population? Well, it depends how we took our random sample here. So I'm going to go back to the stem of the question and let's look at how they took these samples. Okay, we have, let's see, a random sample of ninth grade students from one high school in a rural area. One high school. If it is a random sample from one high school, then we can only generalize the results to that one high school. We can't say all rural high schools, but only this one rural high school. And for the other sample, random sample of ninth graders from one high school in an urban area, once again, it's one high school. So we are not going to be able to generalize this to a bigger population of all ninth grade students. So let's make that very clear here. First of all, answer the question, okay? The question is asking, is it reasonable? And the answer is no, it's not reasonable. And then we have to give some sort of explanation. So we're going to say that the random samples were taken from one urban high school and one rural high school. So we can only generalize to those two high schools. And actually, I'm going to say, so we can't generalize to all ninth graders. Okay, so that takes care of part B, and we can move on to part C, which says, researchers who want to conduct a similar study are debating which of the following two plans to use. Okay, plan one, have each student in the study record all the food he or she consumed in one day. Then researchers would compute the number of calories of food consumed per kilogram of body weight for each student for that day. Plan two, have each student in the study record all the food he or she consumed over the same 7-day period. Then researchers would compute the average daily number of calories of food consumed per kilogram of body weight for each student during that 7-day period instead of 1 day. Assuming that the students keep accurate records, which plan, one or two, would better meet the goal of the study? Justify your answer. Now, here's the deal. If they just did it for 1 day, it would sort of depend on the day. Like some days students eat more, maybe it's Friday night and they go out and have pizza and their calories are higher, and then other days are lower. If we were to do it for 7 days, we would have the lower ones and the higher ones, and then we take the average of those. And that is going to be much more precise measurement of daily caloric intake than the 1 day. So we definitely want to say that we like plan 2 better here. And then we have to explain why. And so I'm going to say that the reason it's better is because we're going to get less variability. If we only pick 1 day, that could be high, could be low. But if we pick the average of 7, it's going to be much less variable. So I'm going to say the lower variability of results in plan 2 would make it easier to determine if there is a significant difference between urban and rural. So that takes you through the model solution. We are now going to talk about how the AP exam graders would grade this. And I need to start by telling you some of the framework that graders use when they're looking at these free responses. And here's the first thing that you need to know. For each part of the question, they are going to give you either an E, P, or an I. And an E means that you have that essentially correct. A P means that you have it partially correct. And then an I means that you have it incorrect. And then at the very end, they'll look at the E's, P's, and I's, and they will convert that into a score out of 4 points. Okay, every free response question is worth 4 points. And I will show you how to do that once we get to the end of this here. So let's go through the grading for part A, and I'll let you know what is needed in order to get full credit on this here. And I'm just going to put this out in the margin here. So I'm going to start with what you would need in order to get an E essentially correct here. According to the rubric, you would have to compare, and there are 3 things that are found on the rubric. They want you to compare the center, the shape, and the spread. And so when we look at this model solution here, comparing the center, we have center here, and we have used comparative words, and the comparison is correct. For shape, we have shape here, and we have compared the shape for the one distribution versus the other distribution. And for spread, we called it variability, and we have a comparative word there that is correct. So we definitely would get an E for this part. Now, to get partially correct, you would have to have 2 out of the 3. Right, so maybe you forgot to talk about the spread, but you talked about the other 2. That could still earn you a partial credit. And then, of course, an I would be 1 or less. Now, a couple of important things I want to point out. One thing you don't see on the rubric is anything about outliers. And there have been rubrics besides this one that have asked about outliers. Also, the other thing you don't see on the rubric is anything about context. And so sometimes it shows up on the rubric and sometimes it doesn't. But as a general rule, you absolutely want to include context, even though you don't specifically see it in this particular rubric here. Okay, so let's move on to part B and talk about the rubric for this one. And this one's pretty straightforward. In order to get an essentially correct, you had to answer the question by saying no and referencing the fact that there is 1 rural high school that was selected and 1 urban high school that was selected, which very clearly we've referenced that and we've answered the question of no, so we would get an essentially correct. There is no partially correct on this one. You either got it or you didn't. So if you didn't have those things, that would be incorrect, which means if you just simply wrote no and you didn't give an explanation, that would be considered an I incorrect. All right, and let's move down to the third part, part C, and let me talk about what you would need in order to get an essentially correct here. Well, the first thing is you'd have to pick the right plan, which is plan 2, and then you'd have to give an explanation, and the explanation has to be based on variability by saying that the variability is lower for plan 2 than it is for plan 1. You could also say more precise estimates. That's the same as saying lower variability. So a partially correct would be if you did choose plan 2, you had the correct plan, but then you had some sort of weaker justification. And then you would get an I otherwise. So I think for our 3 solutions here, we did get an E on part A, an E on part B, and an E on part C. And then we can now convert that into a score out of 4 points. So here's how you convert the score. And you'll notice here that if you got 3 E's, like we did, that would be scored as a 4. If you had 2 E's and 1 P, that drops you down to a 3. There are several different ways that you could end up with a 2 out of 4, 2 E's and no P's, or 1 E and 2 P's. And then also several ways that you could end up with a 1. And if you don't see your E's and P's on there, there is the possibility of getting 0, right? That is also a possible score. So that takes you through question number 1, and I think we are ready for our second FRQ of the day. And for this one, I went to my colleague, Lindsay Gallus, who is also the co-founder of StatsMedic, and I asked her, what is your absolute favorite FRQ? And instead of giving me her favorite FRQ, she gave me her least favorite FRQ. And her explanation was that when she gives this one on a test, it is very, very difficult to grade. It's a lot of work for the teacher. So I thought that we will just include her least favorite FRQ. This is 2017 number 1, known as the wolves problem. So let's go ahead and come up with our model solution first, and then I will take you through the rubric for grading it. So here's what it says. Researchers studying a pack of gray wolves in North America collected data on the length X in meters from the nose to the tip of the tail and the weight Y in kilograms of the wolves. A scatter plot of weight versus length revealed a relationship between the 2 variables described as positive, linear, and strong. Part A, for the situation described above, explain what is meant by each of the following words. Okay, I will tell you that this is a little bit different than a traditional problem that assesses scatter plots and linear relationships. A lot of times you'll be asked to describe the relationship between the 2 variables. But look, they've done that for us, positive, linear, and strong. What they want to know is, what do those words actually mean? And we're going to look at each one of them in part A. So explain what is meant by the following words. So let's start with a positive relationship. And what a positive relationship means that as the X value goes up, the Y value tends to go up as well. But we want to put it in the context of the problem. So as the X value goes up, the wolves are getting longer and longer. So I'm going to say wolves with longer lengths, right? That's the X value increasing, tend to be paired with values of Y that are larger. In this case, they're weights. So I'm going to say tend to weigh more. So the longer the wolf is, the more we expect the wolf to weigh. That's the positive relationship. Now, for linear, we have to talk about what it means to be a linear relationship. And if you think back to your algebra days, linear means that as the X value increases, the Y value increases at a constant slope, right? So let's put that in the context of the problem. I'm going to say as length increases, the weight increases at a constant rate. And when I say constant rate, I'm referring to the slope. So I'm going to even make that very clear here, that there is a constant slope. And then finally, to describe the relationship as strong, well, the strength of the relationship depends on how close those points in the scatter plot are to the form that you've chosen. In this case, we chose linear as our form. And if it's strong, that means that those dots are all going to be fairly close to that line. So I'm going to say the points on the scatter plot are generally close to the line of best fit. And if the dots are relatively close to the line of best fit, then that means that those residuals, which is the error in the prediction, are all going to be generally pretty small. So I'm going to put a little add on here that we have small residuals, right? If those points are close to the line, then we should have small residuals there. So there is our model solution for part A. Let's move on to part B. So the data collected from the wolves are used to create a least squares regression equation. Okay, a couple of things we want to notice right away. First of all, y in this particular context is the weight of the wolf. And then x, the explanatory variable, is the length of the wolf. And we have our values there for the line of best fit. And it says, interpret the meaning of the slope of the least squares regression line in context. Okay, first we have to correctly identify the slope, and hopefully you know that the slope is the value that's attached to the x there, and usually we denote that with the letter b, lowercase b. That is in fact our slope, 35.02. And just a reminder of something that we talked about earlier this week, that in general, the slope can be thought of as being the change in y over the change in x, but for this particular context, change in y would be the change in the predicted weight, and change in x would be the change in length. And we know that this value is 35.02, but I'm going to write it as 35.02 over 1, which is going to help us with our interpretation of the slope, because we know that for a change in length of 1, we predict the weight to increase by 35.02. So we just have to put that in words now. So here we go. For an increase of 1 meter in length, the predicted weight increases by 35.02, and our units for weight is in kilograms. So there we have our interpretation of the slope of the line of best fit. And we are ready for part C. Says one wolf in the pack with a length of 1.4 meters had a residual of negative 9.67 kilograms. What was the weight of the wolf? Okay, so this time we're given the residual. We don't have to calculate it, we're given. And I think what we're asking for when it says what is the weight of the wolf, what we want is the actual weight of the wolf. And so I have to understand how that residual value is calculated. And so just a reminder here that if you're trying to find a residual, it is the actual y value minus the predicted y value, right? A minus P, AP. And listen, we know the residual value, it's negative 9.67. Now, the actual value, we don't know. That's what we're trying to find. So this is the unknown value. So think of that as being like x, that's the variable, the unknown, minus the predicted value. Well, they didn't give us the predicted value for this wolf, but we can calculate the predicted value because we have up here, we have our equation for the line of best fit, which will allow us to find the predicted weight. So I'm going to do this work off to the side just a little bit here. What I need is the predicted weight for this particular wolf. And according to my equation up there, I've got negative 16.46 plus 35.02 times the length. And I know we're dealing with a wolf that has a length of 1.4. So I just plug in 1.4 for x. And if you plug that into your calculator, you're going to get 32.568 as the predicted weight. And that is exactly what we can now plug in for our predicted weight. It is 32.568. And we are left with a very simple algebraic equation to solve here. If we want to solve for the actual value, we need to add 32.568 to both sides of the equation. And this will cancel, and we will be left with an actual weight of 22.898. And I want to make sure I include units in my answer. This is a actual weight, so the units on it should be kilograms. So I'm going to say 22.898 kilograms is my final answer here. So now we need to go back and take a look at the rubric for how this thing was graded, okay? And you're going to find out real quickly here why Ms. Gallus said that this was her least favorite in order to grade. And it has to do with part A here, okay? For part A, in order to get your essentially correct, you have to have a reasonable definition for three different things, the three things you see right here. A reasonable definition for positive, a reasonable definition for linear, and a reasonable definition for strong. And the rubrics on this are a little bit lengthy, and I'm just going to quickly highlight a couple of things, all right? For positive, if you look at the rubric and they want you to describe a positive relationship, here are acceptable responses for that. As length increases, so does weight, which is very close to what we wrote in our model solution. Longer wolves weigh more. Another way of saying the same thing. And the points on the graph go up as you move left to right. Those are all acceptable responses. Unacceptable responses. As length goes up, weight changes. Well, which way does weight change? Does it go up or does it go down? Both length and weight get bigger. Well, does that happen together or in opposite directions? We don't know. And then the correlation is greater than 0, also an unacceptable response there. So I would say that our solution looks okay here because we said longer lengths tend to weigh more. Now for linear, let's look at the rubric for linear. Linear relationship. Here are the examples of acceptable responses. The points generally follow a straight line, which is fairly close to what we wrote. The relationship between x and y is straight, or length and weight have a constant slope. And we did reference the constant slope in our answer. And now the unacceptable responses. The points all line up. Not quite enough there. You can draw a straight line through the points. Well, it turns out you can draw a straight line through any points, whether they're linear or not. There is a positive correlation, or every increase in x yields a 35.02 increase in y, also unacceptable responses. So I think our response looks okay here. We definitely referenced the idea that there is a constant slope. And then finally, the strength. If you look at the rubric here, strong, the acceptable responses for that one. Observed values are close to predicted values. Deviations from the least squares regression line are small, which is about what we wrote. And then you could reference the correlation coefficient being close to 1. Unacceptable responses is to just simply say all the points are close together. It doesn't quite tell you about strength. And the scatter plots are clustered together. It doesn't quite make sense. So you can see why Ms. Gallus had trouble with this one, because the grading of it is kind of a mess. Now for a partially correct here, oh, I'm sorry, I didn't give you the last thing here. Number 4, it has to be in context. And we definitely included context by talking about the wolves and their lengths and their weights. So partially correct would be 3 out of those 4. So maybe you forgot context, or maybe one of your descriptions didn't quite fit into the acceptable bin. And then for an I, it would be 2 or less. Okay, let's move on to part B, and let's talk about the rubric for grading part B. In order to get an essentially correct here, there are 3 components that are necessary to get full credit. The first of which is to correctly identify the slope, 35.02. The second is to talk about how there is an increase of 35.02 for each increase of 1 in x, which is really sort of word for word what we said. We said increase, we said increase, we said 1 meter in x, and then 35.02 in y. And then finally, and this one's really important, number 3, the language you use. It is not the weight that goes up by 35.02. It is the predicted weight, or you could say on average, or estimated. So you have to have one of those types of words in there, rather than saying specifically the weight would increase by 35.02. So partially correct would be to have 2 out of the 3, and an incorrect would be 1 or 0. And then we are ready for part C. In order to get full credit here, essentially correct, there are two components that you need. Number one, the correct calculation for the predicted value of 32.568. And we had our work shown over here. And then the second component is to have the correct answer in the end of 22.898, which we have here. If you have both of those components, that would be essentially correct. Partially correct, you'd have to have just one of those two. And then incorrect would be 0. So I sure hope that we have essentially correct, essentially correct, essentially correct here. And we can now convert that into a score out of 4 points. And that is going to look very similar to the other rubric that we looked at. In order to get our 4, you got to have 3 essentially correct. 3, you're going to have 2 essentially correct and 1 partial. Several different ways of getting a 2 out of 4, and a couple of different ways of getting a 1 out of 4. And remember also that you could get a 0 out of 4. So that takes us to our third FRQ. And this is the favorite FRQ of Josh Tabor, who is an AP statistics teacher in Arizona, has also been a question leader at the AP exam for many years. And if I remember correctly, I think this may have been his question. And I certainly remember spending many days grading this particular question. Now, this should look familiar to you. If you were here with Mr. Murphy yesterday, he used this as one of his example problems in the lesson. And so I'm not going to focus as much time on the solution here because he's already gone through that with you. What I would like to talk to you about is the rubric that's used to grade it. So I'm going to show you the solution first, and then let's talk about the rubric that would be used to grade it. So in part A, you had to identify the explanatory variable and the response variable. In part B, you had to describe whether it was an observational study or an experiment. And then in part C, you had to explain a confounding variable. So let's talk about how this would be graded. So for part A, let's start with what is necessary for an essentially correct. Okay, so this one for essentially correct, both variables are correct. Now, there is a little bit of a hang up on this one. The explanatory variable, a lot of students, I remember this over and over again. I had students that wrote smoking or smokes and wrote Alzheimer's. And that was not enough to earn full credit. That was actually a partial credit. And the reason is this: if you just say smokes, that's not really a variable here. The variable is a categorical variable, which is yes or no to smoking. So you'd have to say something like smoking status or smoking yes or no, or in this case, I've written whether or not the person smokes, which is making it a variable, a categorical variable, where you would record yes or no. And the same thing goes for Alzheimer's. So you can't simply write Alzheimer's. You have to say something about Alzheimer's status, or yes or no, or whether or not. So both variables correct, you get an E. If you had one variable correct, you would get a P. The other way that you could get a P, as I mentioned before, is if you simply wrote smoking and Alzheimer's, that would be good for a partial credit. And the other way you could get a partial credit actually is if you had flipped the two, explanatory and response, but you had defined them both correctly, you could still get a partial credit on that. And then an incorrect would be anything else. Now, moving on to part B, grading this one here, in order to get essentially correct, you definitely had to say, oh, this is not correct. We need to fix this here. This is not an experiment. This is an observational study. And the reason it's an observational study is because there was no random assignment of treatment, specifically the treatment of smoking. They didn't tell some people to smoke and some other people not to smoke. So for full credit here, you have to say observational study. And then you would have to say that smoking was not assigned. Okay, one side note here. It was not enough to just say a treatment was not assigned. You have to identify what the treatment is. the treatment here is smoking. And that was the treatment that was not assigned or imposed on the men and women. So a partial credit here is maybe you said observational study, but then you left off the smoking part. So smoking was missing. You said something about no assignment of treatments, but you didn't specifically say the treatment was smoking. And then I would be otherwise. All right, and that takes us to the last part, part C. And for this one, in order to get full credit, there are two components that have to be included. Component one is that you have to link exercise to smoking. And the way that you see that in the model solution here is saying people who smoke might exercise, and actually I wouldn't say that they would exercise more, I would say that they exercise less, right? You'd think that people who smoke more would exercise less. And so that's component one. Component two is that you have to link exercise to Alzheimer's and say that it influences the risk of Alzheimer's. And you're going to see that in the second part here, exercising more might lower your risk of Alzheimer's. So you have to have a connection between exercise and smoking, and then you have to say how that exercise might influence the risk of Alzheimer's. Now, for a partial credit on that, you would just have one of the two components. And for incorrect, you would have 0 of those components. So after a few corrections on this one, it appears that we have an E now, and an E, and an E. And we can now turn that into a score out of 4. And this rubric is going to look the same as the one that we just went over, right? In order to get a 4, you got to have all 3 parts essentially correct. 3 would be 2 essentially correct and 1 partial. Several different ways of getting a 2 out of 4. Several different ways of getting a 1 out of 4. And of course, there is the possibility of getting 0 out of 4. All right, I do have a homework problem for you that I'd like you to do before Monday, where you will join Mr. Murphy and he will go over that with you. I certainly hope that